These data are from polyphenylene sulfide, and the stoichiometry for polyphenylene sulfide should give us 6 carbon atoms to 1 sulfur, and this should be reflected in the intensity of these peaks that we see in the survey spectrum. One of the features of polyphenylene sulfide is that the photoemission peaks are clustered in kinetic energy, and in particular we've got a carbon 1s and a sulfur very close together, and we ought to be able to produce results from XPS that demonstrate that we have 6 carbon atoms to 1 sulfur. This survey spectrum has been quantified using 2 quantification regions that are defined on the carbon 1s and the sulfur 2s. And these same regions are applied to a set of similar measurements that were all measured from the polyphenylene sulfide at 2 different points. So we have 6 different examples of survey data measured from the same material. So let's now look at what these survey spectra are telling us in terms of quantification using these 2 regions. So if we go here to the text property page on the annotation, and we select the formula option and then say use the active VAMAS block before pressing the apply button, we end up with an empirical formula that gives us the ratio between these 2 materials. So this is sulfur 1 and close to 6, and that's the expected stoichiometry. So let's just propagate that annotation to these other survey spectra, and then let's have a look at these. So the first one, let's get it close to what we'd expect, and then as we step down you can see that we're getting very close to the correct stoichiometry. So these data are quantified, and they're quantified using Scofield cross sections here and here. We've got an effective attenuation length active. We've assumed a magic angle. It really doesn't matter because we've got s orbitals for both of these. And if I do control page up, and let's just look at the relative to 0 plot of the transmission. So you can see here that the transmission is very well behaved, and it's not a surprise then that we're getting a reasonable quantification from these very close peaks here, and using an effective attenuation length and a transmission function with Scofield cross sections.